Section 3.4, the rational zero theorem. We have several notes to take, so pause the video, write the notes, and then resume listening. If f of x is equal to a sub n, x to the nth, plus a sub n minus 1, x to the n minus 1 power, plus all the way down to a sub 1x plus a sub 0, has integer coefficients as p divided by q, where p divided by q is reduced to lowest terms, is a rational zero of f. Then p is a factor of the constant term a sub o. This last number is your constant of the function, and it tells me that p is all of the factors of your constant term. Then it says that q is a factor of the leading coefficient a sub n. So if you have a sub n, that's your leading coefficient, q will be all of the factors of your leading coefficient. So to find all of the possible rational zeros, we will find the factors of the constant term divided by the factors of the coefficient, the leading coefficient. Once those are divided, those are all of the possible rational zeros. So let's apply that to a problem. Use the rational zero theorem. List all the possible rational zeros of f of x equals negative x to the fourth plus 3x squared plus 4. Recall that p is your constant. So my p is positive 4. Q is your leading coefficient, which is negative 1. So we need to write all of the factors of p over all of the factors of q. Well, what are our factors of 4? Well, our factors would be 1 divides into 4, 2 divides into 4, and 4 divides into 4. But keep in mind that factors can be both positive and negative. So my factors of 4, I'm going to write it as plus or minus 1, plus or minus 2, and plus or minus 4. Those are your factors of 4. You divide that by the factors of q. What's your factors of negative 1? Well, that's plus or minus 1. So to actually find all of the possible rational zeros, you will divide every p by every q. So if we divide 1 divided by 1, I still get plus or minus 1. 2 divided by 1, plus or minus 2. And 4 divided by 1, plus or minus 4. There's all of your answers. Now, you may have to write them out individually on the online homework. You may have to write positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. You will just have to see which way that the online homework will accept your answer. But you end up having 6 possible rational zeros. All right, let's look at another example. Using the rational zero theorem, list all the possible rational zeros of f of x equals to 15x cubed plus 14x squared minus 3x minus 2. Remember, p is your constant and q is your leading coefficient. To find your possible rational zeros, you list all the factors of p and divide them by all the factors of q. Well, what are your factors of 2? Your factors of 2 are plus or minus 1 and plus or minus 2. The only numbers that multiply together to give me 2 is 1 and 2. What numbers multiply together to give you 15? You can write them this way: 1 times 15 and 3 times 5. Those are the only pair of numbers that give you 15 and will divide into 15 evenly. So your factors of q would be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Now, to get our final answer, you must place every p over every q. So let's do that. Let's place every p over every q. All right, I'm going to start with 1. 1 divided by 1 gives you 1. 1 divided by 3, that would be plus or minus 1/3. 1 divided by 5, that would be plus or minus 1/5. And 1 divided by 15, that would be plus or minus 1 over 15. Now we will place 2 over every Q. 2 divided by 1, that's plus or minus 2. 2 divided by 3 is plus or minus 2 divided by 3. 2 divided by 5 is plus or minus 2/5. And then last, 2 divided by 15. So plus or minus 2 divided by 15. So we have several possible rational zeros here. Again, you could, on the online homework, write all the positives out and then do all of the negatives. That may be the way that they make you put your answer in on the online homework.